In today's video, I would like to introduce a very nice problem of a Russian mathematical Olympiad edition 2003. Here is the following information. Find all prime p and x, y as our natural numbers such that we have this following equation. We have p to the x as a power of p equals y to the 3 plus number 1. Okay? So in order to solve this equation, so if you take a look again at this equation, we have three unknown variables, p, x, and y. Okay? There is a method. It's very quick to solve this one. Okay? So depends the method you are applying here. If you can do it in hard way, you will find the challenge. If you do it in the easiest way, it will be easier to solve. Okay? Let's jump into the solution. So I would be recommend to give the pre-read into the solution. Go ahead, pause this video when you are come back to see the full solution. Okay? Now let's jump into the solution. So as we know, the prime number could be even, could be odd. Let's assume p is even first. Okay? So if p is even, which means p equals 2. Okay? So I'm simply going to replace this value of p into this equation to see what's given us. I will have 2 to the x equals y cubed plus number 1. So I'm simply going to factor this one out on the form of y plus number 1 as a product is multiplied by y squared minus y plus number 1. Okay? So before I proceed with the solution, I'm going to check the parity of y. Okay? So we know the left hand side of this equation is even, which means the right hand side of this equation must be even as well. So which means y is odd. If y is odd, I'm going to check this side. So we have y squared is odd minus y becomes even, even plus number 1 becomes odd. So the whole term, this one is odd. So this one is odd, this one is even. Okay? But the left hand side of this equation is a power of 2, which means this product must be a power of 2 as well. So which means y plus number 1 is a power of 2, this one is a power of 2. But this one, it's impossible to be a power of 2 because it's odd. Okay? So in order to get rid of this one, and the whole evenness of 2 is going towards y plus number 1, which means this one must be equals 1, otherwise it will be impossible. Okay? So which means y square minus y plus number 1 equals 1. Okay? So I'm going to cancel out number 1 from the left and the right. I'm going to factor out these two terms. I will have y factor y minus 1 equals 0. Okay? We know y is different than 0 because it's a natural number. Okay? Which means this term must be equals 0. Which means y minus 1 equals 0. In the other word, y equals 1. Okay? So I have determined the value of y as a first value. So I'm simply going to take this value of y, insert it into the original equation to find the x. Since we know p and y, I will have 2 to the x equals 1 cubed plus number 1 equals 2. So the exponent equals 1 here, which means x equals 1. X equals 1. So I have the first pair of the solution. I'm going to bring the solution on this side here. So as a first pair of the solution, I will have p equals 2 and x equals 1 and y equals 1. Okay? So let's move on to the next case when we have p is a odd prime. Okay? P is an odd prime, which means p must be super equal to 3, like this. Okay? So I'm simply going to do the general case of this one by factoring out this equation as I did in previous case. We'll have p to the x equals y cubed plus number 1. By factoring out this one, we'll get y plus number 1 factor y squared minus y plus number 1. Okay, like this. Now the parity of y is going to be different. Previously it was odd, now becomes even because this one is odd. Okay, since the left hand side of this equation is a power of p, which means this product is a power of p. Okay, in addition, we know p is a prime, so which means the GCD of this one, it can be 1 or can be p. Okay, which means let's call this one as a capital A. Okay, which means GCD of y plus number 1 of capital A equals either 1 or p. Now we are going to equals D. Let's call D as a GCD. Okay. Now I'm going to determine D. Okay. So which means D divides this term y plus number 1, and also D divides y square minus y plus number 1, like this. Okay. So I'm going to evaluate D. So we have D divide y plus number 1 simplifies by applying the divisibility statement rule. I will get y plus number 1 is a congruent to 0 mod D. Okay, because D divides y plus number 1. Okay, I'm going to take number 1 to the right. I will get y is a congruent to minus 1 mod D. Then I'm going to raise number 2 as a power on both sides. I will get y square is a congruent to 1 mod D, like this. Okay, then I'm going to add minus y on both sides. I will get here y square minus y is a congruent to 1 minus 1, which is 2 mod D. And then I'm going to add number 1 on both sides. I will get y square minus y plus number 1 is a congruent to 3 mod D. So I have two things here. I have this statement. I know D divides y square minus y plus number 1, because we know by the GCD definition, we know D divides this term. Okay. So what this one is telling us, if D divides this one, we have number 3 here. This one is telling us D must be equals 3. Okay, here. If you replace D with number 3, we have 3 here, which means you have a remainder as a 3, which means this one is the same as if you have 0 here. Okay, which means D equals 3. Since I know D equals 3, since D equals 3 equals P as a prime number, in addition, since D divides y plus number 1, since D divides y plus number 1 and equals P equals 3, okay, which means y plus number 1 equals 3. In the other word, y equals 3 minus 1 equals 2. So I'm going to take this value of P and 2 and insert it into the original equation to find x. Okay, so I'm simply going to put 3 to the x equals y2 cubed plus number 1 equals 9. 9 equals 3 square. Okay, now I have determined x equals 2. I'm going to put the second solution. I will have P equals 3 with x equals 2 and y equals 2. Okay, here is only 2 solutions for this equation. So I have ended with this video. Don't forget to support us with your like and subscribe. Thank you for watching. I will see you next video. Bye.